Welcome back to Advent of Code 2025, day 12, the last day of 2025. Christmas tree farm. You're almost out of time, but there can't be much left to decorate. Although there are no stairs, elevators, escalators, tunnels, chutes, teleporters, fire poles, or conduits, here that would take you deeper into the North Pole base, there is a ventilation duct. You jump in. After bumping around for a few minutes, you emerge into a large, well-lit cavern full of Christmas trees. There are a few elves here frantically decorating before the deadline. They think they'll be able to finish most of the work, but the one thing they're worried about is the presents for all the young elves that live here at the North Pole. It's an ancient tradition to put the presents under the trees, but the elves are worried they won't fit. Presents come in a few standard but very weird shapes. The shapes and regions into which they need to fit are all measured in standard units. To be aesthetically pleasing, the presents need to be placed into the regions in a way that follows a standardized two-dimensional unit grid. You also can't stack presents. As always, the elves have a summary of the situation, your puzzle input for you. First, it contains a list of presents, shapes. Second, it contains the size of the region under each tree and the list of the number of presents of each shape that need to fit into that region. So you have 0 and then this, okay, and then here 4x4, 12x5, 12 times 5, okay. The first section lists the standard present shapes. The convenience, the shapes start with index and colon, then the shape is displayed visually. The hashtag is part of the shape and dot is not. The second section lists the regions under the trees. Each line starts with the width and length of the region. Okay, here's width and length. Twelve by 5 means the region is 12 units wide and 5 long. The rest of the line describes the presents that need to be fit in the region. Quantity of each shape of the present. 1, 0, 1, 0 to 2 means you need 1 of index 1, no of index 1 of index 0, no of index 1, 1 present of with the shape of index 2, and so on. Presents can be rotated and flipped as necessary to make them fit in the available space, but they have to always be placed perfectly on the grid. Shapes can't overlap. That is, the hashtag part from the two different presents can't go in the same place on the grid, but they can fit together. So the dot part does not block any other present occupying the space on the grid. I also need to know how many of the regions can fit the presents listed. In the above example, there are 6 unique presents, shapes, and 3 regions that need checking. The first region is 4x4. In it, you need to determine whether you could fit 2 presents with 4, like this. After the exploration, it turns out that you can fit both by going like this. Choop, choop. The second region, 12 times 5, fits 12 units and 5 units long. In that region, you need to try to fit one present with the shape index 0, and so on. So it turns out that these presents can all fit in this region. Here's one way to do it. So you scoop these here, and then go these slanted ones like this. E is here, and C. Okay. The third region is the same size as the previous region, but only difference is that this region needs to fit one additional present with the shape index 4. Unfortunately, no matter how hard you try, There's no way to fit all the presents. So in this example, 2 regions can fit all of their listed presents. Consider the regions beneath each tree. How many regions can fit the presents? Wow, that's really interesting. It's like a bin packing kind of problem. In these regions, you need to fit a lot of them. How many regions can fit? Let's start with this. The parsing. Maybe I don't want to even read the lines. Read text. And I can split at /n/n lines. Okay, let's use lines again. Ooh, it's not happy. No, it is happy. The last one is the regions. Where can we again split? The first I'm splitting the double lines, and the last one is this, and I can split the single lines. And I can map those to regions where I have first part is the whatever it is. Size is, choose a point. A one, and then indices. So region has, just choose the point here, and then list of int. I can map the regions. Then I can go the parts are lines dot drop last map. I don't really know how to encode this. Block. So the index is block dot split. And then shape is block dot split. Um, New line, drop one, cast the index, and then oh look, they all have the same shape here as well. Mm. They're not exactly the same, but they're very similar. Anyways, it's just 3 lines, a list of 3. Hashtag, I can just leave it like that maybe. What is? See. Okay, so we have the regions and the parts. Now we need to map them. So for part 1, interestingly, it's surprisingly easy. So after mapping all these regions, I was trying without squeezing different shapes into each other, just assume everything to be a 3 by 3 part. So if this is a 3 by 3 block and so on, do they then fit into this grid? So basically I can just ignore this and just sum over how many 3 by 3 grids are required and see if that um, area that they would take, which is the amount of this, times 9, because 3 by 3 is 9 area, that is smaller than the area for each. So I can just go result is regions map, sum these indices, how many um, 3 by 3 things I need. Then I check is this amount times 9, do this fit into the region? So is it smaller or equal to the region's area, which is x by x times y? And then I count those that are true. It's 422. And that's correct. So we don't even have to do any squeezing. For the example here, we do need to have the squeezing where we overlap them, but apparently for the real one, it didn't really matter, which is kind of odd. And I wouldn't have known how to do that. But yeah, we got the answer for this. So we're on to part 2 for the last day. The elves thank you profusely for the help and start rearranging the oddly shaped presents. As you look up, you notice that a lot more elves have arrived at the Christmas tree farm. In fact, many of these new arrivals look familiar. They're the elves you helped while decorating the North Pole base. Right on schedule, each group seems to have bought a star to put on top of the Christmas trees. Before any of them can find a ladder, a particularly large Christmas tree suddenly flashes brightly when a large star magically appears above it. As you as your eyes read read readjust readjust readjust, you think you notice a portly man with a white beard disappear into the crowd. You look at a ladder, only 23 stars to go. You have enough stars to finish decorating the North Pole? Because we got the 23. So let's see. Now it starts snowing. You help the elves decorate the Christmas trees with all 24 stars. Now the elves will have plenty of time to prepare for Christmas and you get a well-deserved break. And it's done. Now we have highlighted Easter eggs and it's starting to snow. So everything is solved for this year. Thanks everyone for viewing and I'll see you soon.